Okay, so now we're back and we're going to look at some patterns with our graphs. So some of our graphs are going to open up and some of our graphs are going to open down. So right here we have a graph that opens up. This graph is y equals x squared. And then over here we have a graph that opens down. And this graph is y equals -1 x squared. So what's the difference? Well, this one has a +1 and this one has a -1. So what happens is when we have a quadratic function written as a quadratic equation, y equals ax squared plus bx plus c, this a is really important. The value of a determines the direction that it opens. If our number in front of x squared is positive, it's going to open up. If our number in front of x squared is negative, it's going to open down. Now, the point at the very bottom of this one is known as our vertex. And because our graph opens up, this vertex is also known as our minimum value, because it's the lowest that the graph goes. And then over here, the highest part of my graph is my vertex, and it is known as my max because it is the highest that my graph goes. So if my graph opens up, this vertex point is the lowest point, also known as minimum. If my graph opens down, it's now going to be my highest point, known as my maximum. Now, we also have domain and range of a quadratic. We talked about domain and ranges before, and we're going to talk about them again because it's always good to pop up with it and bring back this vocabulary. Domain talks about all possible x values of our graph. Range talks about all possible y values. Now, with quadratics, unless a specific domain is given, you may assume that the domain is all real numbers. And if you remember, we used a little sign for that. There was like a double line, and then we made the R for all real numbers. It is also known as all possible numbers. So we start any number from -infinity to +infinity. That is our all real numbers. Now, if our graph opens up, then our range or our y values are always going to be y is greater than a number. And this number is going to be the y value of our vertex. Now, if our graph opens down, the range is going to be y is less than, because remember how our vertex, when it opens up, our vertex is the lowest number possible. So all of our y's will be bigger than that number. But if our graph opens down, that is the highest value, which means all my y values will be lower than that value. So as we move into our first problem, our domain should be all real numbers. So x equals all real numbers. And that's really because my graph keeps going forever side to side. Now my range, because this is the very lowest value I have for y, should be y is greater than, because everything is above that y value, of 2. Because that's where my vertex hits, is at that y value of 2. So now if I look at the next problem, my domain should be all real numbers. And my range, because it opens down, should be y is less than or equal to a certain number. So what's my highest point? My highest point's right there, and that y value is 5. So my y value should be less than or equal to 5, which makes sense because when we look at this graph, all of these values are below that 5. So everything below the 5 on the y-axis. So now we're going to put some of our vocabulary to work. Identify the vertex. So where is my vertex at? That's this point right here. And this point has a coordinate of -2 and +5. My domain should be all real numbers, because it's always all real numbers, because my graph goes forever in the x directions. Now my range should be y, and then remember this opens down, so this is my highest point. I want everything lower than here, so lower is less than or equal to this value right here, 5. So on my next problem, my vertex is right here, and that has a coordinates of x is 3, y is -1. My domain should be all real numbers. And my range, because my vertex is the lowest point possible, I want everything bigger than that. So y is greater than or equal to this y value of -1. Okay, so we're not done. These are just, it's really just kind of learning the vocabulary and what's going on here, learning the bits and pieces. Now we're going to talk about where the graph crosses the y-axis. Oops, these are flipped around. So where it crosses the y-axis is the y-intercept. Where it crosses the x-axis is the x-intercept. And where it crosses the y-axis, y-intercept will have coordinates of 0, comma, wherever it touches. So this is an actual point. My y-intercept is a point where it crosses the y-axis. And so we do the coordinates. X value is 0, y value of wherever it crosses. Now our x-intercept will have coordinates of the x value, comma, 0. Because at each axis, the opposite axis has a value of 0. So on any part on the x-axis, all of those points have a y value of 0 because of where it crosses. So now we're going to take a look at the graph. We're going to determine the y-intercept. So this is my y-axis. So my y-intercept has an x value of 0, and then I put in the y value, which is 3. My x-intercept, there's actually 2 of them. So with my x-intercept, it crosses here, and it crosses here. So my first one has an x value of -1, y value of 0. And I have a second one, and that's possible. Sometimes we have 2, sometimes we have 1, sometimes we have none. And this one crosses my x-axis at 3, and then my y value is 0. So with the intercepts, if it's a y-intercept, we know the y value. So the other one has to be 0. So let's look at this one. My y-intercept is 1. So my x value is 0, the y value is 1. My x-intercept, down here where it crosses my x-axis, there's only one of them. That x value is -1, and the y value would be 0. So now we're going to put all this stuff together. One last final push. Find the vertex, the domain, the range, x-intercepts, y-intercepts, and determine if A is positive or negative. So this is going to be problems that you're going to see on your test. So here my vertex is right here. It has coordinates of -1 and 1, 2, 3, 4. My domain should be all real numbers, like always. My range, well, this is the highest, so all my y values should be lower than that 4. Keep in mind, you see how that 4 matches up with that vertex? That always happens. And then we're to our x-intercepts. Now this is tricky because I can't tell exactly where it's crossing. So if I can't tell exactly, I'm going to do a little approximate, a squiggly equal sign saying, okay, this is somewhere around -2.5 and 0. And then over here is somewhere around -0.4 and 0. So again, just kind of approximately. Forgot my squigglies there. So I'm throwing them in. And then we're going to go ahead to y-intercept. Ooh, that one's nice. It's right at 2. So my y value is 2. And then now is what's happening with our a value. Well, this opens down. So a is negative. Okay, we're almost there. One last problem. Okay, let's start with our vertex. Is 1 and negative 3. Our, let's see, domain, all real numbers. Our range, well, it opens down, so this should be a less than or equal to, so it's everything's less than negative 3. Our x-intercepts, well, it doesn't even cross the x-axis, so there's none. Our y-intercept, oop, looks like it crosses right here, so 0, negative 6. And then a, well, it opens down, so a is negative. And that's it. So we'll see you next time.